Yeah, good evening, children. Welcome back to our class of SAT, and let's continue with the number system series. So, we have done so many things till now. We have been doing quadratic equations, then curves, then graphing, so many things. So, let's move on to the number system now. So, children, when I talk about number system, it involves everything that is connected to numbers. So, number system is very large context, but what we do is very small. From that huge, we do very little of it. So, let us see what we do and how we proceed. See here, of course, number system means what? It contains plenty, which you have been doing right from your class 5 onwards. So, I don't think there is any need for us to give all those introductions again. Now, we have done enough of times. So, therefore, let us move to the problem solving directly. So, if you look at this, when the integer n is divided by 2 and the quotient is u. So, u into 2 plus remainder is 1. That will give you the number, that is n. So, when the integer n is divided by 5, its quotient is v and the remainder is 3. So, that means what? 5 into v plus 3 equal to n. That is second equation. So, look at that. N equal to 2u plus 1, that is what I said, 2u plus 1, then 5v plus 3 equal to n. So, if you equate these two, you will get 2u plus 1 So, 2u plus 1 equal to 5v plus 3. So, now one of these two should be, it should be there. So, 2u minus 5v equal 3 minus 1 is 2. So, this is the final answer. You have option B with you, children. So, please note it fast, quick. So, children, only thing, of course, we all know this, there is nothing new, nor I am not telling anything new. Divisor, number, quotient, remainder. So, now this is q into d plus r equal to n. This is the logic. Quotient into divisor plus remainder equal to the number. Okay. So, this is the logic I have used. So, we get it. Right, children? So, let us move to the next question. So, look at this. Yeah. Suppose P is equal to Q, P is even, it's not equal, P is even and Q is odd, then which of the following cannot be an integer? P is even, Q is odd. So, now P plus Q means what? Even plus odd. Even plus odd is odd, divided by even. Odd divided by even every time, it need not, it cannot be an integer. So, anyway, so now only 1 is true, or only 2 is true, 3 only is true, and 1 and 3 are true. So, as we discussed, P is even, Q is odd means P plus Q is odd, and odd divided by even number is, is not an integer. So, now what is that he is asking? Then which of the following cannot be an integer? Means compulsorily which cannot be an integer. See, possibilities, yes, no, yes, definitely it is no, and other is maybe, or yes, 100% yes, like that. There are three cases: 100% yes, 100% no, maybe, possible, like that. Okay. So, first one is 100% ruled out. Okay. So, now P is even, Q is odd, even into odd by 3, it could be an integer, because it depends on whether what is P and what is Q. Therefore, we cannot say that it cannot be an integer. So, it is possible. So, therefore, 2 I am not sure whether it is an integer or not. It could be or it could not be. So, now Q is odd by P square. P square is what is P given as? P is even. So now, if you take this, Q is odd, P is even. Now what is that he asked you? Third option, Q by P is even, Q is odd. Now Q by P square. Q means what? Odd. By P square, even square. So definitely this cannot be an integer because even square is even, odd by even is not an integer. Therefore, only one satisfies, children, only one satisfies, okay. So please note it, quick. So not integer. A also we got it as not integer, so option D, children, not this. This is not integer, this is not integer, this is possible to be an integer. Therefore, option D satisfies. Quick. Finished. So let's move to the next one. Yeah. A, B and C are consecutive integers and A is smallest of all and C is largest of all. Which of the following must be true? So now children, look at this. If I say A is n or B is n, A is n minus 1, C is n plus 1, correct or not? Consecutive integers, yes. So where n belongs to an integer. Okay. So now B minus C equal to minus 1, not plus 1. So option 1 is wrong. ABC by 3 is an integer. Yes, definitely consecutive numbers, if you multiply, it is always divisible by 3. Therefore, is an integer. This is true. This is wrong. A plus B plus C is even. See, suppose this is odd, so this is also odd and this is even. Odd plus even plus even. No, sorry, odd plus even plus odd is even. Suppose this is even, this is even, this is odd. Then even plus even plus odd is not, even. So therefore, this need not be true. So only option 2 satisfies. Okay, children. So better take this. It's all not required. So here I think every explanation is there. B minus C is 1 is there. ABC equal to an integer, it is there. A plus B plus C. So it is odd plus even plus odd is even. Even plus odd plus even is odd. So therefore, this is not true. I think every explanation I have given on the board, please note it fast, quick. Okay, children. So I think you have followed this. Let's move to the next question without wasting any more time. I think you all are clear. B minus C is minus 1. We have proved it. ABC by 3 is an integer because it is always divisible by 3. Even if you take not 1, 2, 3, you take 2 into 3 into 4. Divisible by 3, like that. Compulsorily it is divisible by 3. Therefore, second is true. Third one, A plus B plus C, we have seen. Here it is even, here it is odd. So he says always even, that is wrong. I think this should be very clear. Let us move to the next question, children. Yeah. So if both x and y are prime numbers, which of the following cannot be the difference of x and y? So he said prime numbers, whether they are continuous numbers or how they are, we don't know. So you can take any number, 1, 9, 9, 23. So now let us take both x and y are prime numbers. Which of the following cannot be difference of x and y? So if you take the numbers as 3 and 2, so 3 minus 2 equal to 1. 3 minus 2 equal to 1. So this is possible. So what is that he says? Which of the following cannot be difference of x and y? So 1 cannot be is wrong because it is possible. Here we are seeing. So maybe you take some other numbers 5 and 2 as prime numbers as we have shown here. And 5 minus 2 is 3. 5 minus 2 is 3. So this 11 minus 2 is 9. So this eliminates C, and maybe this is 3 children. This is 3, not 9, because 2 places it cannot be 9. So if it is 3, then it is eliminated. Okay. This is also eliminated. This is also eliminated. This is also eliminated. So now what happens? So if you take 23, difference of x and y. So now we should take 2 numbers, prime numbers. So 23, see all prime numbers are what? 2, 3, 5, 7, 11, 13, 15, 17, 19, sorry, not 15, 17, 19, 23, 25, 27, 29, 31, and 35, 37, and so on. So if you take difference cannot be 23, we should check. 29 minus 3, no, not 23. 29 minus 6, it's not possible. 31 minus 8 is 23. So 8 cannot be the thing. 37 to 23 means 14. So 14 cannot be a prime. Therefore, option is D, children. Okay. So this is only by elimination method we are trying, and we are taking examples and proceeding. Please note it fast. See children, here you may get a doubt, then if this is the case, how did we get here and here? See, the reason is simple. These two cases and this case used 2. So therefore, if you take 2, all other prime numbers are odd only. Odd minus odd is always even. Odd minus odd is always even. Odd minus even is odd. See, you see you all have odd numbers, correct or not? If you should get 23, don't even need to write all these numbers and check. Apply your brain, think, and you get ideas. See, suppose you want to get 23. Second prime number should be 25 and first prime number should be 2. Then only you will get this 23. So 25 is not a prime number. Therefore, this is not possible. So why to take all these and check? I just showed you, but it's not compulsory. Apply your brain, you'll get it. All other prime numbers are odd. 2 prime numbers difference other than 2 is even. So therefore, it cannot be 23. And if you have to get 23, you should use 2. If you use 2, the other prime number should be 25. But 25 is not a prime. Therefore, this is not possible. Okay, children. So that's how you can work it out. So any question? No. Okay. So let's move to the next question. So let's look at this. You see, if the remainder is 1 when m is divided by 2, when m is divided by 2, you are getting remainder as 1. and the remainder is 3 when n is divided by 4. Which of the following must be true? M is even, he says. So m is divided by 2, remainder is 1. So therefore m is even is wrong, because when you divide a even number by 2, you will not get remainder 1. So this is wrong. So now next is what? N is even. So n is even means what? When n is divided by 4, it leaves a remainder 3. If n is even, whenever you 4 multiples if you take, they all are even only. 4 multiples you take, they all are even. So the remainder cannot be 3. So even this is ruled out. Okay. So now mn is even, he says. So m is not even, n is also not even. Therefore, product of two odd numbers is odd. So this is also ruled out. So automatically this should be the answer, children. Okay. So please note it fast. Okay. So now here you see what we have done. Did we do the same analytical work? See what I did there, I just used logics. I did not solve the problem. So now, is it really possible without solving? Yes, it is possible. We have done it. Now, what is that we have to do mathematically to prove that? Now look at this. Here we have shown. So, when you divide this, number m by 2, you will get a remainder 1. So, the quotient be u. So, m is 2u plus 1. Next, let the quotient be v. So, 4v plus 3 equal to n. 4v plus 3 equal to n. See, this is odd. This is odd. Okay. Sum of two odd numbers is 2u plus 1 plus 4v plus 3, that is 2u plus 4v plus 4. You take 2 common, you will get 2 into u plus 2v plus 2. Is even, he said. Yes, it is even because you are getting 2 common. Now third, mn is always odd. Odd into odd is odd. So we have done mathematically here. Analysis also explained. Note both the things, please, quick. Okay, children, let us move to the next question. I think you have followed this logic. Let's move to the next question. Yeah. If x and y are both prime and greater than 2 means both are odd. Okay, greater than 2 he said, so both are odd. Then which of the following cannot be a divisor of xy? Which of this cannot be a divisor of xy? See, when 2 is not there, multiplication of two numbers x and y, two odd numbers is odd, xy is odd. So odd cannot be divided by 2. So this we have. So here, can this be divisible by 3? Yes. If x is 3 or y is 3, then it is divisible by 3. 11, yes, you have one of the prime numbers as 11. 15, 3 and 5, yes. So therefore, only possibility is 2, children. So please note it fast, quick. Okay children, let us move, but anyway, just we'll write odd into odd is not divisible by 2. Okay children, so let us move to the next question. Look at this. If 2 is the greatest number that will divide evenly both x and y, what is the greatest number that will divide evenly both 5x and 5y? So 2 is the greatest number, he says, divides evenly into x, so x is 2 times something, okay. So 5x is 5 into x, we know it is 2z, 5x is there, 5 into 2z, that is 10z. So this should be divisible by 10, this should be divisible by 10, okay. So now this z may be multiple of something odd or even, what it is, it doesn't matter, so this should be divisible by 10. So 5y, if you take 5 into y, so 5y is also divisible by 10. How it is? 2 is the greatest number that is divisible by even both x and y. So therefore this should also be a multiple of 2. So 5 into 2 times something, instead of z you can take, it's like this, x is 2z, so y is some 2p, something like this. So 5x is 5 into 2z, that is 10z. So 5y is 5 into 2p, that is 10p. So therefore both are divisible by 10. So since 10 is the greatest number that is divisible, so this is the answer. Okay children, please note it fast, quick. Okay children, let us move to the next question. If average of consecutive even integers a and b, a, b and c is less than 1/3 of a, if the average of consecutive even integers, so let us say 2n is first even integer, second even integer is 2n plus 2, third even integer is 2n plus 4, right children? So what is that he says? The average of consecutive even integers a, b, c, average means 2n plus 2n plus 2 plus 2n plus 4 by 3 is average. So what is this equal to? 2n plus 2n, 4n plus 2n is 6n by 3 is 2n plus 2 plus 4 is 6, 6 by 3 is 2 is less than a by 3. What is a by 3? This is a comma b comma c equal to this. A by 3 is 2n by 3. So 2n by 3 is always lesser than 2n plus. So this is lesser than this, he says. So which of the following best describes the value of a? So now look at this. He says 2n plus 2 is less than 2n by 3, right children? So look at this. So cross multiply 6n plus 6 is less than 2n. So 4n is less than minus 6. So n is less than minus 3 by 2. N is less than minus 3 by 2. Okay. So now what is that he says? A is a prime, A is negative. A is what here? 2n. N is negative, so 2n is minus 3. So A is negative is suitable thing. A is positive is wrong. A is 0 is wrong. A is a prime, need not be prime. Okay. Note it children, quick. less than minus 3 by 2, sorry. Less than minus 3 by 2 means you can take minus 2, right? So minus 2, if you take minus 2, 2n is minus 4 anyway, so negative. Please note it fast, quick. Okay children, let us move to the next one. Yeah. So now look at this. If x plus 5 by y is a prime integer, x plus 5 by y is a prime number, which of the following must be true? So now look at this. Let us take some numbers. Let us take some numbers. If x is 1 and y is 3, example, okay. If x is 1 and y is 3, then what is that? Y, it is not equal to 5x. Y is not equal to 5x because 5x is what? 5 ones are 5. 5 ones are 5. So 5x is 5 and y is 3, which is not possible. Y is equal to 5x is not possible. Now let us go to x plus 5 by y, third one. X plus 5 by y, x plus 5 by y. So 1 plus 5 by 3, 6 by 3 is 2. So what is that? He says this is odd, which is not odd. Therefore this is wrong, this is wrong. So y is a prime integer, 3 is a prime integer, so it is possible. Okay children, so option C satisfies. Which of the following must be true, he says. Y equal to 5x is not true. So this is not the answer. So it should be option number 2. Please note it fast, quick. He says it is y equal to 5x is right, it is wrong. Acha, so that is, oh sorry, we have to see this, no? So only 2 satisfies, this is right. So y is a prime number. How it is none? We have option 2. Y is a prime number, it is there. Acha. So y is a prime, 2. Oh, good children. Yeah children, now let us rediscuss this question, why this is wrong, okay. So now, what is that he says? This we are not looking, this we are not looking. X plus 5 by y is a prime integer, he says. So now look at this. So there should have been one more word, that is odd, odd prime integer. So now look at this, when we take this x is 1 and y is 3, you are getting x plus 5 by y, this is odd, which is not right, that is okay. So y equal to 5x, so y is a prime integer, yes we are getting 5, but it is not odd. So we should say and even and odd, sorry. It should have been like this. It should have been like this. Not odd, it should have been even, suppose. So children, there is some small change in the question. If you have to look at this answer as none, if you have to look at answer as none, then you have to change the question. So what I say is, instead of changing the question, better let us work with the things what is given. So with the given things, option 2 satisfies. So let us take option C, okay. Let us not take this answer, let us take the solution as a prominent. Please note it fast, quick. Okay, children. So if this would have been is an odd prime, then this would have been wrong. This would have been wrong if you would have said an odd prime, right, children? Please understand the differences. So just sometimes many students, not sometimes, many times what students do is they keep the answers open and they start working out with those answers. Suddenly they get something, when they don't find that answer same, they change the answers and they keep on writing there. So don't do that. If he would have said odd prime integer, then this would have been wrong. But he did not say odd prime, therefore this is right. Only prime he said, so therefore this is right. So just by seeing answers, don't change the questions, okay, children? Or don't say that question is wrong. Many times I have seen many students doing this. What they get is right. If they don't get right answers, they'll say question is wrong or answer is wrong. Please don't do that. Please note it fast, quick. Okay, children, let us move to the next question. Look at this. If x is both the cube and the square of an integer, cube and as well as square of some integer, and x is between 2 and 200, what is the value of x? So, children, this is a very important and very beautiful question. So, x is both cube means something whole cube and something whole square is x. X is something whole cube and as well as something whole square also. And it is a number between 2 and 200. So now he is asking to find out the value of x. So now look at this, children. See, ABCD options are given. We can eliminate options and we can check. So he is asking you to find out the value of this. So definitely 8 is not square of some number. Okay, 64. This is the one which is square as well as cube. Square as well as cube. This is square but not a cube. This is cube but not a square. Therefore, option is C. Okay, please note it fast. Quick. Okay, children. So let's move to the next question. See, you have to copy this. I have been asking every time to take a screenshot, but still today I had a discussion with one student. They were saying, sir, you are going fast. You are not giving us time to copy. So I said, okay, then if that is the case, I told you to take screenshot. Okay. So if you take screenshot, I am giving you this much time. I think taking screenshot, you have time. Okay. Still, the second method. See, you all are given options of listening to recorded lectures. In case, let us say you could not take screenshot, right, children? But you have access to the portal where recorded lectures are already posted. So what you can do is you can start playing that lecture, then stop wherever you could not note, copy it. Right, children? So I am giving you so many options, so many techniques, so many methods of learning things. Please apply yourself. Don't be in irritations. Don't be in trying to get everything spoon fed. Spoon feeding will never work at this level of working. You need to be active and effective enough of doing things on your own. I am telling you because I got this to my notice. If suddenly something do not come to my notice, then how will we work? So are we going to give up? No. And second thing is, if I start giving you more time for copying alone, we are not able to do much. We have to complete the thing. So if teaching part, if there is any problem, you please let me know. Not in terms of copying or something. If you have any problem in teaching part, please get back to us. We'll help you. We'll arrange some additional classes. We'll arrange one-to-one class. Even we are arranging one-to-one classes, children. One student we are calling, we are arranging a class and we are clarifying doubts. No need of going for any tuitions anywhere. We are doing everything that you need. So therefore, please feel free to talk to us and ensure that your doubts are clarified. Okay, children, so let's move to the next question. In the 2-digit number x, both the sum and the difference of the digits is 4. Oh, this is really good question. What is the value of x? So in a 2-digit number x, both the sum and the difference of its digits is 4. So children, can you guess what could be the answer? Oh, no one trying to answer. Children, sum and difference, how can be it same as 4 if one of them is not 0? And it's a 2-digit number, so first digit cannot be 0. So therefore, look at this. Sum 4 plus 0, 4. 4 minus 0, 4. 3 plus 1, 4. 3 minus 1 is not 4, like that. 1 plus 3, 4. But 1 minus 3 is not 4. Anyway, this, it does not happen, this cannot happen. 4 plus 8, it's not 4, it is 12. He says it is 4. Therefore, option is very clear, it is C. But when sum and difference is same, automatically the second digit should be 0, children. So this is very, very important. Please note it. No need of working so much. Directly you can write. Okay, children, let us move to the next question. Look at this. If p is divided by 9, it leaves a remainder 1. Which of the following must be true? See, when some number is divided by 9, it is leaving a remainder 1. Means all multiples of 9 are odd. 9 ones are 9, 9 twos, 9 twos are 18. Whenever it is multiple with even number, it is even. So now, what is that he says? It should be, remainder should be 1. Okay. So now, p is even, he says. P is even, he says. See, 46 is even number. When you divide that number with 9, you will get a remainder 1. But why p should be even? You take 19, 46, remainder is 1. 19, then also remainder is 1. 9 twos are 18, remainder is 1. So this is even, this is odd. So this is wrong. P is odd. Here we have seen 2 examples. Wrong. So p is 3z plus 1 for some integer z. So some integer z means what? P, when you divide, so look at this. Here we are giving. See. This is 3z. 3z. Briefly review the concept of divided by 3. Leaves a remainder 1. Okay. P is 3z plus 1. So now, children, yes. So look at this, children. So we are thinking in terms of 9. See, P is what it is. I mean, remainder is 1. You remove this. So now, other numbers are what? 9 ones are 9, 9 twos 18, 9 threes 27, like that. So every 9 is divisible by 3. So, but is it for some z, he says. So should this be true for all? Should this be true for all? So now look at this. P is this actually. It is divisible by 9 and leaves a remainder 1. So it should be P is 9q plus 1. So that is 3 into 3q plus 1. So 3q, I am replacing it by z. See, but this z is multiple of 3. Z is multiple of 3. But it's not true for universal values. So it should be, z should be compulsorily 3q. So therefore, this also, this statement C also is not true for everything. This is true for only z is a multiple of 3 children. Okay, that's why some integer, some word is very important. This is not for every integer. If I say every integer z, it is wrong. For some integer z, then it is right. So that what is that some integer? It should be multiple of 3. So please note this fast. Please take a snapshot of it quick. I'll go for next page fast, children. Okay, children, let's go to the next page. So please note it fast. See, this is very important, children. Z is 3q. It is multiple of 3 only, not for every integer. It is only for multiples of 3. 3, 6, 9, 12, 15, like that. Okay, please note it fast, quick. Please take snapshots, children. Otherwise, we are wasting a lot of time. Okay. So you need to copy it, or otherwise, as I said, in case if you are forgetting to take snapshot at any stage or at any point, you all are given access to the recorded lectures. Open the recorded lecture, go through that, and wherever you could not take a snapshot, please stop there. That's movement of the movie or the video. Stop it there. Note it and then proceed. Right, children? I am giving you all the hints, all the methods, how to work on, how to use technology, that is integrating technology in your learning process. I am giving you every method, so please follow. If anything is there, still talk to us. We will help you and guide you. Okay, children? Let us move to the next question. P and Q are integers. If P is divided by 2, the remainder is 1. So P is divided by 2. So P is something 2Q plus 1. So is there Q anywhere? Yes, Q is there. So I cannot use Q here. So something like L, I use 2L plus 1. So this is P. And Q is divided by 6, leaves a remainder 1. So Q is divided by 6, M plus 1. So which of the following must be true? PQ plus 1 is even. PQ plus 1 is even. So this is odd, this is odd. So PQ is odd into odd is odd, plus 1 is even. True, 100% it is true. Odd plus 1 is always even. Right, children? PQ by 2 is an integer. PQ by 2. So PQ by 2 means what? Take it. This into this, 2L, so 12LM plus 2L plus 6M plus 1. So from here you cannot take 2 common. Therefore, it's not an integer. So ruled out. PQ is multiple of 12. PQ is multiple of 12. Not sure. So therefore, leave it. Okay, children. So PQ is what? Is it sure or not sure? PQ, odd into odd, is odd. Odd is not multiple of 12 compulsorily. Odd is not multiple of 12. Multiples of 12 are only even. Therefore, this is 100% ruled out. So, only option 1 satisfies. Okay, children, please note it fast. So, please note it. Okay, children, let's move to the next question. Yeah, look at this. The smallest prime number greater than 53. Smallest prime number greater than 53. So, these all normal number, children. So, I don't think we need to solve it. Please note it, that's all. Quick. This is just numbering. You should know what all are prime numbers, and immediately above 53, whatever is there, you take that. That's all. So, I think this we need not solve it. So, you could have understood what is it. I think there is no need of explanation also. You take a prime number immediately above 53. That's all. So, next question, children. Which one of the following numbers is the greatest positive integer x such that 3 power x is factor of 27 power 5? This is also simple question, children. Look at this. 27 power 5 can be written as 27 is 3 power 3 whole power 5, that is 3 power 15. So, now what is that he says, which one of the following numbers is the greatest positive integer x such that 3 power x is a factor of 27 power 5. So, from this you should substitute and see. 27 power 5 is 3 power 15. So, 3 power x, what should be the greatest integer? So, 15 only. Highest number is only 15. So, please note it fast, quick. So, okay, children, let's move to the next question. Look at this. If x, y and z are consecutive integers in that order, which of the following must be true? So, whenever he says consecutive integers, I will take n minus 1, n plus 1. So, generally I prefer to take that, children, like that. Why I prefer to take it like this means sum of all three numbers means you will get some n directly. Okay, that is another integer. Okay, that is the only reason. Otherwise, if you give some other rules, based on the rules I will take. I can't say that every time this type of picking up will give you solution or easily or whatever it is. So, therefore, just by habit I am taking that. I don't know if it really simplifies the process or not. Let us look at it. So, progressions, arithmetic progressions, we use generally the terminologies of arithmetic progressions and proceed. So, xy is even, xy is even. So, what is this? N square minus n. So, when they are consecutive, children, definitely if this is odd, this should be even. If this is odd, this should be even. If this is even, this should be odd. So, compulsorily xy is even is right. X minus z is n minus 1 minus n minus 1. So, that is minus 2. So, that is even. So, x minus z is even is also right, even integer. Okay. X power z is even. X power z is even. So, let us say this is 3. 3 to the power of 5, not even. Always it is not true. If this is 4, if this is 4, 4 power 6 is even. So, sometimes it is true, sometimes it is not true. So, therefore, option 3 does not work out, only option 1 and 2 works out, children. Please note it fast, quick. Okay children, so let us move to the next question. So look at this. If the sum of two prime numbers x and y is odd, then the product of x and y must be divisible by any of this. If sum of two prime numbers x and y is odd, so sum of two prime numbers is odd means always all odd numbers except 2 are odd only. So he says sum of two prime numbers means other than 2, if I take anything, odd plus odd is even. But he says x and y is odd, that means compulsorily 2 is coming into picture. 2 is coming into picture. 2 plus something is odd. So 2 plus odd number is odd. Okay children. So now therefore compulsorily it should be divisible by 2. Compulsorily it should be divisible by 2. So option 1 satisfies. Please note it fast, quick. Okay children. So I think everyone has followed this discussion. Let us move to the next question. See, here he gave x plus y. I am not able to see that clearly on the screen, so I am rewriting this. X plus y by x minus y is 3 and x and y are integers, then which one of the following must be true? X plus y by x minus y is 3, he says. X and y are integers, then what? So you can take x is 2, y is 1, suppose. So x plus y by x minus y is 3 by 1. So that is 3. Then one of the following must be true. X is divisible by 4, not true. Y is an odd number. Yes, y should be an odd number because if you take x as 3, y is 0. So y is an odd number is not true. Yeah, y is an even integer. Y need not be an even integer if x minus y is positive. So x is an even number. So yes, if it is 3, then x should be an even number. So option should be D. Right children? So please note it quick. So I think we had enough discussion of this. Of course, we have to do some more questions, but most of these questions are general. Mathematically, very little need to be done. Generally, a lot can be done in these type of problems. We have seen sometimes we have started mathematically, but again we have gone back to the normal techniques, that is in the previous problem. Before this you have seen like n minus 1, n and n plus 1 I have taken, but afterwards I did not use that n minus 1, n and n plus 1 concept, but I tried to solve it generally only. So therefore, these type of problems are generally, worked out using normal methods rather than mathematical things. Of course, we have done even mathematically also, but it's mixture, I can say. Rather than following one technique, we have to follow multiple techniques. Right children? Have a great day. Wish that you practice these things and grow and get 800 out of 800 in maths of SAT. Thank you.